Signals and system. A signal is an varying physical parameter which carries some information. We can say, for example, an electrical signal, an video signal, or an acoustic signal. So we have a lot of applications on signals, maybe mostly in the medical fields, in the communication fields, and so on. Okay, so the signal, basically we have two types of signal. One is continuous time signal and the other one is discrete time signal. A continuous time signal is represented as a function of t and discrete time signal is represented as a function of n. So this is how a continuous time signal looks. For an example, I am taking a sinusoidal waveform. This is called continuous because the signal is appeared at any given point of the time. So I can choose any point here on the timeline and I can say there is a signal appearing at that point. So now if I sample this continuous time signal, that means if I start dividing this continuous time signal like this, and if I put it on the other waveform, so this is called discrete time signal. So now if I see, so see here, if I take at this point there is no signal, but if I take somewhere these points, the signal is there, but the signal is not there at every given point of the time. The signal appears at only distinct time value. So such signal is called as discrete time signal. When a continuous time signal is sampled, we get discrete time signal. So for an example of a continuous time signal, we can say all analog signals are continuous time signals and all digital signals are discrete time signals. Okay, so now let us first try to define some elementary signals. First one, unit step. And unit step is denoted by u of t for continuous time signal and u of n for discrete time signal. So from now on, whenever I write u of t or any function of t, it is for continuous time and a function of n is for the discrete time. So let's draw the signal here. So I'm taking the origin O here, origin O. Now unit step looks like this. It starts at 0, the amplitude is 1, as the standard definition says, it's unit. So the amplitude is 1 and it continues to go until infinity. So again in discrete, so this is how the signal looks. It starts from 0 and it continues to go up to plus infinity. So here I can take the time values as 0, 1, 2, 3, 4, 5, 6 and so on. Okay, so let us try to define this. Unit step is defined as u of t is equal to 1 when t is greater than or equal to 0 and 0 when t is less than 0. So you can see here for t less than 0 there is no signal in both the cases, right? So that is why it is 0 when t is less than 0, and when t is 0 or greater than 0 the amplitude is 1. So u of n is 1 when n is greater than or equal to 0 and 0 when n is less than 0. So this is unit step. Next one, unit ramp. So unit ramp is represented as r of t or r of n. So r of t and this is for r of n. Let me draw the signal. So when you look at the signal here, so you will understand that this is an linear signal. Okay, so this is 0, 1, 2, 3. So this is up to infinity, up to infinity. So let's try to define this. R of t is equals to, now I said this is a linear signal. So that means when the time value is 1, the amplitude is 1. When the time value is 2, the amplitude is 2. So as t varies, the amplitude R of t also varies. So I can say R of t is equals to t when t is greater than 0. See, at 0 the amplitude is 0, so there is no need to mention equal to, okay? Or you can also say because t is 0 at 0, and then it is 0 when t is less than or equal to 0. Next, R of n, it's n for n greater than 0 or 0 for n less than or equal to 0. The next signal, unit impulse. So unit impulse is represented as delta t or delta n. Alright. As the name says, so impulse, which is a sudden appearance. Okay, so delta of t is equals to 1. When is the amplitude? We have 1 here. When t is equals to 0. And what happens when t is not equal to 0? When t is not equal to 0, it is all 0. So 0 where t is not equal to 0. So you all have to learn to write the definitions looking at the given signal, or when a definition is given, you must be able to draw the signal. So 1 when n is equals to 0 and 0 when n is not equal to 0. Okay, so this is all about the elementary signals. So in the next video, we will learn about classification of signals.